Welcome to this installment of the PowerMux Deep Dive, where we will discuss the integrated protection and features TI PowerMuxes offer. To introduce the protection features our PowerMuxes offer, let's take a look at the internals of our TPS2121 PowerMux device, which we will discuss in further detail in the following slides. This device offers adjustable priority setting, which enables the users to select either manual or automatic control and establish a user set switchover voltage. Overvoltage protection protects against voltage surges, while thermal shutdown disables the device when the temperature exceeds a set threshold. Soft start control reduces the stress on downstream components by controlling and reducing the inrush current during startup. Current limit lowers peak currents during inrush events. And now let's discuss these all in more detail. Since PowerMuxes are located at the input of a system, a major concern is overvoltage events. These events can occur when the wrong connection to the PowerMux is made, or when there are any voltage surges on the input. As a response to these events, once an overvoltage condition is detected, the device is disabled as a response and automatically retries when the input voltage drops below the user set threshold into a valid input. To set this overcurrent threshold, the overvoltage pins are connected to the input voltages through a voltage divider. Each overvoltage pin is compared internally with a constant Vref voltage. Once the node is greater than or equal to Vref, the input is marked invalid until overvoltage falls below Vref. To set what resistor values are needed for the desired overvoltage condition, the following equation can be used. In addition, overvoltage pins can be externally triggered using a microcontroller to pull the pin high to manually trigger one or both of the supplies invalid. Overcurrent protection is shown in PowerMux devices by current limiting. By clamping the current to a user set value, current limiting lowers peak currents during inrush and short circuit events. To implement current limiting, a pin is provided. By placing a resistor from the current limit pin to ground, the device is able to protect the system during high current events by clamping the current at a user set value ILIM within TILIM seconds. Equations are provided in the PowerMux datasheet to calculate what resistance is needed for the desired current limit. Provided is an example for calculating the current limit given a resistor on ILIM. Soft start control protects against uncontrolled inrush current and reduces the stress put on downstream components. Soft start is user configurable using an external capacitor, which allows for a controlled startup. This soft start feature is used during any initial startup event that the device goes through, but not during a switchover between two validated rails. Once a supply ceases to be valid, as in the supply drops below the undervoltage threshold or above the overvoltage threshold, soft start occurs again and as the supply becomes valid again. Here's what you would expect to see in a data sheet to calculate your slew rate based on your capacitor. Thermal shutdown ensures the device disables during high power and current limiting events before the device reaches an unsustainable temperature. Once the device hits a SIT threshold, noted in the datasheet as TSD, the device disables until the temperature falls to a set hysteresis value, marked as TSD hysteresis. As we know from the first segment of this PowerMux deep dive, TI PowerMuxes are in a preferred break before make configuration, which ensures no reverse current flows during a switchover event, since the first channel is disconnected to the output before the second channel is disconnected. This leaves a time, however, where no voltage is connected to the load. Since this voltage drop occurs during every switchover event, as the PowerMuxes chooses one supply over the other, another important specification to look for is the switchover time. Switchover time, or TSW, is the time it takes for the output voltage to stop dipping after a switchover event. By minimizing this time, we reduce the voltage drop on the output during a switchover event. This specification can be found in the electrical characteristics of any of our PowerMux datasheets. In this video, we have discussed protection features for TI PowerMuxes. For more information on PowerMuxes, please visit ti.com/PowerMux. And for more information on how to design your next power design, check out our 11 Ways to Protect Your Power Path ebook, which serves as a great resource in identifying what protection is needed for your system.